I am a tutor in Uplatz. Today we are going to discuss about automotive embedded applications 1. Restraint system repairs is one of the important applications in automotive embedded application systems. Objective: explain the difference between an active and a passive restraint system. Learn how to service seat belts. Describe the operation of airbag system. Repair or bag system safety. Introduction: a restraint system is designed to help hold passengers in their seats. Restraint systems prevent passengers from being injured during pollution. All new vehicles come equipped with some form of restraint system. Active and passive restraint. An active restraint system is one that occupants must make an effort to use. Conventional manually operated seat belts are classified as an active restraint system. A passive restraint system is one that operates automatically. Two types of passive restraint systems are automatic seat belts and airbags. Seatbelt systems. Seat belts are strong nylon straps with special ends attached for securing people in the seats. Lap belts extend across the lap and shoulder. Straps extend over the chest and shoulder. Seatbelt anchors allow one end of the belt to be bolted to the body structure. A seat belt retractor is one to remove slack from the belts where they fit snugly. Seat belt reminder systems use a warning system to remind the driver to fasten the seat belt. Passenger seat airbag, warning light, forward sensor, driver's side airbag, electronic control module, in-car sensor, passenger side dash mounted, driver side steering wheel mounted. Emergency locking retractor assembly, seat belt anchors, shoulder belt latched, shoulder belt unlatched, seat restraint system includes seat belts and airbags, normally under computer control. Note the location of major parts. To study the major parts of the seat belt system, buckles, latches, and the belts themselves must be in good condition before release to the customer. Is a child seat anchor plate, rear belt, shoulder anchor adjuster, front seat belt, front seat buckles, rear center belt, and rear seat belt buckles. Seat belt service: do not intermix the types of seat belts on the front or the rear seats. Avoid bending or damaging any portion of the belt buckle or latch plate. Always replace lap and shoulder belt retractor mechanisms or lap belt retractor covers. A visual and functional inspection is important. Check for twisted or damaged webbing. Replace the assembly if the buckle will not latch or if it does not lock when the brake is applied. Child restraint system and airbag safety. Child restraint system is a removable appliance available from most automobile dealers. Restraint seats are available in either the rearward facing or forward facing models. The seat is intended to be ideally secured with the vehicle's shoulder or lap belt. The seat should never be used without the special security clip. Late model vehicles are equipped with internal seats built into the rear seat. Airbag systems. An airbag system automatically deploys a large nylon bag during severe collisions. Driver's side airbag is mounted inside the steering wheel center pad. Passenger side airbag is mounted behind a small door in the side of the instrument panel. Side impact airbags deploy from the door panels or from the side of the front seats. Rear seat airbags fit into the rear cushion of the front seats. All airbag systems have similar parts: airbag module, inflator mechanism, and nylon bag that expand. Airbag system sensors, inertia sensors that the signal computer of pollution, control unit, computer that operates the system, and wiring harness, wiring and connectors that link the system parts, dash indicator lamp, dash bulb, that warns of system problem. Study of the major parts of an airbag system. We have the clock spring airbag module, the right impact sensor, center impact sensor, left impact sensor, wiring harness, tunnel sensor and shaping sensor, driver seat door switch, control module. Airbag module is composed of nylon bag and an ignited mechanism. Airbag is a strong nylon bag attached to the metal frame module. Airbag ignited pushes a small spark when electrical signal is sent from the control unit. Propellant charge is sodium acide, which converts to nitrogen gas as it burns. Knee bolster cushions the driver's knees and prevents the driver from sliding under the airbag. The driver airbag module mounts in the steering wheel. Note part and location. Inflator cover, spiral cable, inflator module, steering wheel, airbag, ignited charge, squib, gas generant pellets, steering wheel pad, screens, cruise control switch, airbag sensors. Impact sensors are the first sensor to detect a collision. Arming sensor ensures that the particular cushion is severe enough to require airbags. Inertia sensors detect a rapid deceleration to produce a electrical signal. Seat cushion sensors detect the weight of a person sitting in the passenger seat. Controller analyzes the input from the sensors to determine if airbag system deployment is needed. Inertia sensor, direction arrow, electrical connector, front vehicle, unibody. The inertia sensor detects rapid deceleration from body impact on the front or side of the vehicle. It sends a signal to the computer to deploy the airbag. Inertia sensor must be installed with the arrow in the right direction. Also make sure the system is disarmed so that the new airbag does not deploy while working. Airbag system servicing. Before servicing a vehicle equipped with the airbag, the system must be disarmed. Always disconnect the negative battery cable. Even with the battery disconnected, an energy reserve module can deploy the airbag. After airbag deployment, use a sharp vacuum to clean the passenger compartment. Residual power, ice, skin irritant can be present. Figure shows after airbag deployment, the passenger compartment should be vacuum cleaned, wear eye protection and respirated before removing the deployed airbags. Passenger airbag deployment often breaks the windshield. The side airbag deployment can damage the inner trim panel. Airbag system servicing. Airbag system parts are replacement of the deployment will vary. To remove the deployed airbag, remove the small screw from the rear of the steering wheel, wear safety glasses and the respirator. Inspect all the parts for the damage and any parts with visible damage to be replaced. When carrying a live airbag module, point the bag and trim cover away from your body. When installing new airbag parts, always follow the service manual instructions. Here, a technician is installing a new side airbag on the road. Stay to one side and keep the head away from the airbag during the installation to avoid injury. Airbag system performs a self-check every time the ignition is turned on. The on portion will complete, the lamp should go off. Make sure a final sweep is made for both or collision information using the approval scan tool. Recheck the wire and harness before releasing the car. Check to make sure the sensors are fully fastened to the mounting fixtures and all fuses are correctly rated and replaced. Summary: active restraint system is one that occupants must make an effort to use. Passive restraint system operates automatically, such as automatic seat belts and airbags. Child seat may be rear facing, front facing, or a combination. Most airbag systems have an airbag module, airbag system sensor control unit, wiring harness, and dash indicator lamp. Safety applications, airbag systems. Here is a airbag ECU diagram. It consists of a 32-bit MCU, multi-core lock step RX, with REG, Automotive PMIC, function safety valve jack, satellite sensor interface, pressure sensor from the door, ADL XL, PNX, and pressure sensor from the other door, pedestrian protection sensor IC, yaw roll pitch plus low G XYZ sensors, CAN transceiver, CAN bus or LIN bus, reversible pretensioners, LAN transceiver, then script driver 8-channel, wiring SPA bus, script driver channel and script driver 8-channel, buckle switch, two buckle switches, warning lamp, airbag off, some multiple script for 8 script for the script driver 8-channel and 4 script for the script driver 4-channel and 8 script for the script driver 8-channel. System benefits: airbag system are standard in most cars and are mandatory equipment in many countries, saving thousands of lives. Infineon's product spectrum supports scalability and flexibility for building systems from 4 to 12, over 20 firing groups, full range of airbag ASSP ranging from pressure sensors for side crash detection to driver and transceiver ICs, high performance 32-bit RX MCU family with dedicated safety features enables integration of multiple functions. The pods are optimized in terms of both system interoperability and the best place performance ratio. These systems are mandated in order to achieve the highest possible scores in various new car assessment programs throughout the world. Microcontroller RX, high performance 32 multi-core microcontroller, power management IC, REG, Automotive PMIC, network transceivers, CAN FP and LIN transceivers, airbag ASSP, airbag deployment, ASSP, airbag satellite receiver, pressure sensor, XCN, SIV application specific sensor for side airbags, pressure sensing, XC1, SIV application specific sensor for side airbags, pressure sensing, fully PSI5 compliant, XEN, SIV application specific sensor for pedestrian protection sensing, SIV magnetic sensors, XEN, SIV all switch for buckle switch application. In vehicle networking complexity, in 1996, typical vehicle 6 ECUs, 2009 IN vehicle 70 ECUs. There are so many motors and flaps, immobilizer, seat modules, alarm, rear module, HVAC, lower door modules, rear lighting, RKE and TPMS receiver, body controller gateway, steering column, rain sensor, sunroof, lighting L, lighting right, SJB, temperature sensor, wipers, blind spot detection, battery management, instrument cluster, radio, navigation display, amplifier, video, engine management, airbag, occupant classification, driver seat belt tensioner, pause seat belt tensioner, sensor cluster, anti-lock braking, adaptive cruise control, park assist suspensions, active steering, power steering, transmission, chassis management, fuel pump, NOx, engine management, glow plug, cooling fan. Vehicle EER, entirely now challenges, too complex, too much energy consumption, too many different networks, too many ECU, too many cables, too many conductors, too much weight, too many. With further adaptation of vehicles, a global rethinking of electrical engineering architecture is needed. New trends in vehicle networking architecture, vehicle diagnostic access, central switching gateway, C2X, Ethernet, main engine controller, transmission, energy management, CAN, flux ray, chassis, satellite one, stability control, main chassis controller, main ADA AS controller, reverse camera, park assist camera, blind spot detection, DW, Ethernet most Infotainment controller, HMI satellite, telephone information satellite. One main body connector controller, body satellite one, body satellite two, body satellite three, body satellite four. LIN and CAN are used as bus. Higher ECU integration emergence of the domain controller will create new challenges in terms of functional safety. ISO 26262. Architectural evolution, Ethernet in automotive. Why Ethernet in vehicles? Well-known technology, widespread knowledge, wide availability tools. Ethernet can handle future bandwidth requirements for multiple inline in-vehicle applications. Unshielded twisted Ethernet-based network significantly reduces cost. Unified Ethernet architecture, ESS diagnosis and maintenance. Ethernet AVP audio profiles can substitute synchronous modes. Ethernet example-based informant and network architecture. Ethernet AVP for informant, peripheral functions and upgrade options. Trunk, communication, telematics, audio amplifier, Ethernet AVP, Ethernet switch, AVP, navigation engine, digital radios, Ethernet AVP, much stream audio control, car network gateway MCU, Ethernet service control, Ethernet AVP switch, gigabyte Ethernet, panorama view, ADAS, MPU, LVDS, rear, raw video, YED unit, infotainment MPU, switch, gigabit Ethernet, Ethernet, dual stream audio video, multi-stream audio video, service control, LVDS, raw video, front view camera, dashboard, cluster MCU, SPI, ECU, media server, infotainment MPU, NAND flash, USB iPod, audio display, rear seat entertainment. Example of free-scale MPC 5668G dedicated gateway MCU built on power architecture, 208 MP PBGA 17 mm by 17 mm. Objective functional safety objective of the ISO 26262 standard provides an automotive specific risk-based approach for determining risk classes ASIL, specify the necessary safety requirements for achieving an acceptable risk, provides confirmation to ensure a sufficient level of safety is being achieved. Functional safety, ISO 26262. Functional safety is a key paradigm of the next generation electronic vehicles system. Safety standards are becoming the key enabler for the design of all new electronic applications in the vehicle and associated semiconductor development. P-scale number one in automotive semiconductor. P-scale leadership in driving standards. The first semiconductor supplier to join the AutoSAR development partnership, co-founded X-ray consortium with BMW, Tesla and Philips, founding member of local interconnect network LIN consortium, founding member of the DSA protocol and associated member of the PSI5 consortium, Airbag, member of Gen IBA consortium, Infotainment, active member of JASPAR, supporting Japanese automotive electronics standardization. Thank you.